This is Milani, Chapter 13, Section 1. In this section, actually, I am covering the 13.1 and 13.2, which we are going to find the critical point, increasing, decreasing, relative mean, and relative max. Then, the first thing we have to find the domain. By looking at this problem, I am dealing with the natural log. When you're dealing with the natural log or a log, means you have a restriction. In order for you to find the domain from the natural log, whatever you have after natural log, you set it bigger than 0. Solve for x. Move the minus 9 to the other side is become positive 9. We are trying to solve for x. Divide both sides by 3, which is x is going to be bigger than 3. That means my domain is going to be from 3 to positive infinity. But don't forget, I do not have an equal with the inequality here. That means next to this 3 has to be parentheses. Now, this is the common mistake which the student mess up the increasing, decreasing if they do not pay attention to the domain. That's the reason I'm going to draw the line. Right away, I would indicate this 3 here. That means it would remind me less than the 3, there is no x value. To find the critical point, we have to find the derivative. Derivative of x is 1, and the derivative of a natural log, this 5 is the coefficient, which I'm going to carry it down. And then derivative of a 3x minus 9 is 3, divided to carbon copy 3x minus 9. This is the calculus, but we need to simplify. The first thing I can see, in this part I have a 3, I have a 3, and I do have a 9. All my 3 numbers is dividable by 3. Then the top one I would reduce by 3. And then this one is gone, and this one is gone. It's become 3. Then, if it is okay with you, you can find the LCD, work on it, or if you want it, this 5, you can multiply it by the 1. That means this 5 goes as a numerator. You can rewrite it like this, and then get the LCD. Now, LCD, multiplication of all denominator. I have a 1 here, I have a x minus 3 here. That means my LCD is x minus 3. Then, I will multiply x minus 3 by the numerator and denominator. Then, from here, I'm going to get the common denominator, and then top is going to be x minus 3. X minus 3 times 1 is going to be x minus 3, then minus 5, which I get x minus 3 minus 5. Now, remember, you cannot reduce this minus 3 by this minus 3. If you have more than one terms in the top or a denominator, you cannot reduce. Then, minus 3 minus 5 combined it, which is become minus 8. This is simplified derivative. Then now, it is much easier to work with this one from now on. If my derivative is the fraction, you can set the whole fraction equals 0, solve for x for the critical point, or you can just set the numerator equal 0, solve for x. However, it is easier for you to do it that way. In my PowerPoint, I'm going to just go by the shortcut. I would just set the numerator equals 0. Then solve for x. Move the minus 8 to the other side. It's become positive 8. That means the x coordinate for the critical point is going to be 8. Now, to find the y value, for any point, it doesn't matter. You always go back to the original problem. That means you have to find f of 8. Now, in my PowerPoint, I'm going to give you the answer, but make sure you recalculated yourself. Then, my critical point when the x is 8, my y is going to be minus 5.5. That this is the critical point. Now, I need to find the increasing, decreasing. For the increasing, decreasing, I'm going to first label my critical point on my line. Then, I have to go to the testing point on the first derivative. Now, in order for you to find the testing point, you look at your critical point. I have just one critical point. If I have one critical point, that means I'm going to have two testing numbers. One number in the left side of the critical point and one number in the right side of the critical point. Now, left side, don't forget, I have a restriction. X cannot be less than or equal than 3. Pick any number less than 8, but it has to be bigger than 3, which I'm going to choose the f prime of a 7. Pick a number in the right side of the 8, which I'm going to choose any number larger than the 8. I would choose the 9. Then, I made it easy. I actually have my derivative here, then it would make it easier for us to see it. Your choice. You can replace the 7 by the numerator. 7 minus 8 is become minus 1. 7 minus 3 is going to be 4. That means minus 1 over 4. You can have your number, actual number here, or you can just have a sign. That means when I replace the x by the top, when it was the minus 8 is the negative sign. When I put it in the denominator, it's become 4 is the positive. That means negative divided by positive, which is going to be negative number, which we know it was minus 1 over 4. But it doesn't matter whichever you do. You can just say minus 1 over 4 here, or you can have this fraction and then negative. If I replace the x by 9, right here, 9 minus 8 is going to be 1, which is positive. 9 minus 3, which is 6, is positive. It means positive divided by positive is going to be positive. If the answer is negative, means decreasing. If the answer is positive, means increasing. The left side of the 8 is going to be, I'm going to mark it as a negative, means decreasing. In the right side, I mark that area as a positive, means increasing. Now, right here, decreasing, that means my graph is going down this way. Here is positive. This means increasing. That means from 8, my graph is going up. Now, by knowing this one, now I can write down the answer for increasing, decreasing. relative mean and relative max. First, increasing. From here to positive infinitive is going up. That means it's going to be 8 to positive infinitive. Decreasing. This part is going down from here. But don't forget the restriction on your domain. That means x has to be 3 to 8. Now, relative max. Relative max is going to be increasing to decreasing. By looking at here, I don't have it increasing to decreasing. That means the relative max is going to be none. Then, relative mean. Relative mean means decreasing to increasing, which I have it right here, which remember, when the x is 8, my y was minus 5.5, and that is the conclusion.